Okay, so let's carry on because we're a little bit behind on time. Mandi is going to talk about InSpec, following on the DevSecOps seed that Mark sowed earlier. So I'll hand over now to Mandi Walls. Thank you.
I added a little bit about Test Kitchen in here because I realized I was probably not talking about Test Kitchen enough with some folks, so it's a super cool tool. We're going to talk about it a little bit as well. So I am Mandi Walls. I work for Chef. I've been at Chef 6 years. Chef's about 10 years old, so I am like internet ancient dog years chef person, basically, in that space. Currently I'm the technical community manager for Europe. I am based here in London. We have an office in Moorgate. You're welcome to come say hello sometime. If you'd like to get in touch with me at any time, my email address is there, as well as my social media handle on anything but Snapchat, because I'm way too old for whatever is going on with Snapchat. In addition, the tool that I'm going to talk about tonight is called InSpec, and we have a dedicated community manager for this tool. His name is Adam Leff, and he's actually based in the Washington, D.C. area, so a few hours off of London, but this is his handle as well, Adam Leff. I've been around DevOps for a long time. I pulled this Building DevOps Culture cover up. It's a white paper I wrote for O'Reilly actually in like 2012, and it's just like, oh my gosh, it feels like it's been so long. But Chef has been a big player in that, and some of the things that we've been working on are around not just DevOps and sort of configuration management was our original piece, but now InSpec is a sort of new tool, and we have some other things that we've been working on. So as we've been part of the DevOps movement and part of the sort of IT modernization, a lot of our customers and the people we work with are really coming around to the idea that every business is a software business, versus 2003 Harvard Business Review was like, outsource everything, no one cares about technology, just don't do it anymore. And one of our keynotes for our conference a couple of years ago was the CIO of Alaska Airlines, which is a still functioning regional airline in the United States. He basically said that they're a software company with airplanes. So millions of dollars of capital expense in airplanes, but their user experience and their improvements in their process and the new features they're able to bring to their customers really fall out of their software process and technology, which was super interesting. And that talk's actually on our YouTube channel if you're interested in it. So we've been working a lot with improving workflow, working with continuous whatever, right? Delivery, deployment, integration, blah, 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 the whole 9 yards. And part of our initial messaging was, of course, around the reproducibility of infrastructure, right? You have a web server, you want to build another one tomorrow because you got more users, you want it to be exactly the same. So through that, there's also been this discussion of pushing more and more things to the left, like adding more complex processes to the beginning of your application development workflow rather than sort of tacking them on to the end. And we started to see this, and I certainly experienced it, in working with security and compliance updates in large production environments, that it's a lot of stuff that gets tacked on to the end, and it's very hard to manage that complexity. So what we were seeing was applications would get really, really fast, teams would get really good, and like they'd hit a freaking wall, right? Like the security team would be like, this is a great idea, but you've violated all of our rules for how to run this in our data center, or the things that can be open to the public and all this other stuff. So you'd end up with this great big just dam of ideas, and you have like all these things, and security would be like, not gonna do it. And there's legitimate reasons for this. You think about how DevOps got started and why Dev and Ops were sort of at odds. Like security, there's definitely reasons for them to be concerned about the things that the application engineers or the operations engineers are putting into production, because it costs real money. And we're on the cusp of GDPR, which makes this even more crazy as far as what the costs end up being for a breach. So some of the things that we've been looking at last fall, this breach in the United States. So HIPAA is our Health Information Privacy Act, and for customers, patients in the United States. And from an IT standpoint, these things are pretty simple. Like this fine was levied against this company. They failed to change the default settings on a server. And we're like, dude, we know all about default settings for configuration management. And preventing these sorts of sort of simple configuration problems is something that should be doable with technology. Additionally, as WannaCry sort of cycled and then reappeared and then recycled and reappeared, looking at how companies are managing these fast-moving environments and a new deployment and how you manage to get all of your good stuff every time you need to deploy new environments. And this Honda plant basically had fixed everything. They were beautiful, their WannaCry stuff was all gone, and then they redeployed something from base images, and it's like, oh, well, you screwed that up because you didn't patch the base images. So these things are not hard to do, but we want people to think about the security and compliance stuff every step of the way. So what our tool will do is provide a set of rules, a profile of rules for your teams to use or to consume at every step. So they'll be part of the full workflow that you get from the time that your software engineers sit down and do Java or Python or PHP or Node or whatever they're working in, all the way through towards your operational deployment on Linux or Windows, right? And that's what InSpec's going to help us do. So InSpec is a human-readable specification language. It's for tests. So the methodology is structurally different from something like a Tripwire or like an intrusion detection system, right? So those who deploy, they take a big catalog of all the activities that are on the system as it currently stands, and then you run to see if things have changed. So it's different from that methodology in that I am saying, these are my requirements, and I've written them out in this sort of human-readable language, and I want to make sure I'm always meeting those requirements. So it includes these facilities for creating, sharing, and reusing what can be very complex profiles. Thinking about the CIS standard for Linux, which is like 500 pages of PDF. It's something absolutely ridiculous. And it covers a lot of minutia about the system and the things that are sort of the recommendations for locking down sort of a baseline Linux system. There's just a lot of stuff in there. And those profiles exist from various different services in the US and abroad, and cover a lot of different platforms. There's just a lot of things in there, you want to be able to use them. So the other part that sort of makes it super interesting is that, yes, you can build off of these sort of default security principles, but you can also add in your own compliance stuff for how you manage Java or how you manage your PHP applications. And it's all, then you can add all that stuff into the extensible language that comes with the InSpec system. There's also command line tools. We'll take a look at those, and it integrates with a tool called Test Kitchen, which I'll talk about in a little bit as well, so you get sort of this fast feedback as you're making all your changes. So for basic stuff like SSH, right? Like working in a Linux space, which I was a sysadmin for a long time, like you get to the point where you think, oh yeah, this is the way things should be done, and then you get a new version of your preferred operating system from your distribution, and they haven't made that change. Like they're behind the recommendations or whatever. So you want to always be sure that what you're doing is up to your specification for your environment. So for something like SSH supports all these protocols. We're going to make sure that we're only using protocol 2. It's probably the default everywhere, but in case it's not, we want to make sure that we're still correct and we're still meeting this requirement. So how do we go about fixing this? If I've got 1,000 or 1,500 machines, like how do I figure out, like, I need to make sure that I'm in compliance with this rule that I got in an email, right? So I figure out where the file lives. Is it in /etc/sshd or just /ssh or wherever the heck it is? I figure out how to do some sort of like magical incantation. Am I going to check it first? Am I just going to push a new one out and hope that's okay with what is already out there? I don't know. Are you feeling lucky? Well, let's see. Then for my images, if I need to build a new machine tomorrow, how am I sure, like in the Honda case, that the new machine that I build is still going to meet my specifications? So if I had to make a change, I need to backport that into my images and make sure that's okay. That might actually be another team, and I have to be ticketed with those guys because they only do this like once a quarter, and you're all like, oh, damn, we have to remember how to do this every time. So maybe we're using configuration management for that. We hope that you are. Not everyone is. So we have these new components for all of our life cycles. So we get this mandate from security, figure out, all right, well, how often does this actually happen? Maybe we do a single big scan. We've worked with some customers that they'll call us up and they'll be like, we just did our audit and we need some help with blah, blah, blah. And you're like, you need help with like 5,000 nodes? How often do you do this audit? We're like, oh, once a year. Really? How often do you push your changes? Every couple of weeks. That's not a good idea, right? So you get these big mass scans, remediation fire drills, and all these things, while the rest of your life cycle is pushing towards be faster, get things out quicker, do things at a bigger pace. So introduce the InSpec to this entire life of chaos, right? So it lives at InSpec.io. The stuff that I'm going to talk about tonight is all open source, so there's no commercial aspect of the things that I'm going to talk about. There's commercial components to it. I'm happy to talk offline about those later. The way that it works, the spec part is the hint. So in Chef Land, we live a lot in Ruby, and one of the Ruby testing tools was RSpec, and this sort of follows, sort of inherits from some of that life. So for something like SSHD config, I don't want to think about, is the location of SSHD config different on Ubuntu and CentOS? I don't care about that, right? And I shouldn't have to. My tool is going to say, all right, you're asking me for SSHD_config, I'll go find that for you. I can give an impact statement. Is this important? Is it a warning? Do I care? Do I not care? Do I just want to know that it's there? I get a title, so that when I break things down, I can find it easily. And then I get this big description. And this is a super important thing we found with like compliance officers who have a big binder of printed out documents of things that you need to follow for the things that they care about. And they don't necessarily have to be the most technical people or know the ins and outs of your bash shell or anything else, but they know that you have these things that they need to meet. And you can actually encode them right into your InSpec tests so that they can follow through and audit and say, oh yeah, you've met all of these things that I care about. And then the last part is the actual comparison. So I get into the file, I look for the protocol, and figure out what the value is. So we call these resources. These are built-in things to the InSpec tooling that give you an insight into the system and the places that you want to look for components. And there's a whole big list of the current ones. There's a bunch of stuff that are for sort of every platform, and then there's a bunch of stuff that's been added that's sort of Windows specific, right? Because registries and other components only live on Windows, and those things are supported there. So then the resources, we dig into them and we figure out what their characteristics are, so we know what we can search for, what we can compare it to, what that actually ends up looking like. So in our example, my resource is actually SSHD config, and under the covers, InSpec does all the work figuring out where that file actually lives on whatever system that I'm looking for. So there's lots of things that I can check for, right? Thinking about the requirements for a security protocol, things like NFS should not be running, or some random package should not be installed. Even things that are a little bit more complex, like this library should be updated to this version or higher based on the CVE that we got, right? So we can actually put those things sort of in there and compare them to the live running system. And then we can run it. So InSpec has a command line. I can use it to talk to I can use it to check my local machine that I happen to be on, or I can use it remotely. It is installed as a Ruby gem, or you can bring along the rest of the Chef Developer Kit, which has some other tools in it. You can run it remote against the target, and it's not changing the target host. So in some places, it's a little bit different from other tools in this space, where it's not actually installing software on that target. It's running those commands remotely, so that what's actually being tested is the system as it lives. So there's none of that sort of Heisenberg uncertainty system of going, if I've looked at it, doesn't mean I've changed it. No, we aren't changing it. There's also a REPL, if that's your thing. Some people find this kind of weird. And then it integrates with Test Kitchen. So we can test out all kinds of targets. If I'm working locally, I just run it. I have my tests in a Ruby file. I execute them on my local machine. If I'm working remotely against a Linux system and I'm using SSH, I borrow all the connector options from SSH to connect into my system. I can run it against Windows with WinRM, and I can get into Docker containers if I'm running them in Docker Engine, and I can look at them there, especially for things like security vulnerabilities or other library versions and stuff like that. So that you can integrate it into your workflow, it uses 0 non-zero return codes. Super easy, right? If I have any failure in any of the tests in my suite, I will get a non-zero return code so that I can plug this into my Jenkins workflow or my Travis workflow and say, when you have deployed all of this thing, does it still meet my requirements for security and compliance? And then when it's all good, you get 0 and you can move on. So one of the really interesting places it integrates is with a tool called Test Kitchen. Is anybody already using Test Kitchen? A few folks brave enough out there. So Test Kitchen is a test harness for infrastructure code. It's a tool that was built out of our Chef community a number of years ago to sort of help people manage local development on their workstations with virtual hosts in Vagrant and usually something like VirtualBox under the hood. So you have locally installed images on your workstation that are live running systems, but you use them to do sort of local development before you check your code in and your teammates get bugs from you or whatever. So you can do a lot of testing locally. And it allows you to integrate a lot of also infrastructure tests, which is where InSpec sort of falls, is that under this sort of infrastructure test environment. So it also lets you run your preferred configuration management. Mine is Chef, yours might be different. And then our infrastructure testing tools is part of our workflow. So it gives you this fast feedback, and you just plug it into your kitchen.yaml. So here I'm going to cross my fingers and hope that things still are running okay on my machine here. And we will turn off mirroring here quick. I always forget the shortcut. There we go. So what I have in my environment is a CentOS, I think it's 7.2 machine. Yep, CentOS 7.2. And the definitions are in YAML, and I'll take a look at that file here in a second so you can see it. But it's installing an image that I've downloaded sort of a base box for. So we use these a lot, so we publish some under a project called Bento. There's other stuff out there. There's millions of them, really. And it downloads it and starts running it. And then I have some things in a Chef recipe that it's going to run for me. So I now have this virtual machine running here that I've defined. And in my kitchen.yaml file here at the bottom, I have the option of also running test suites. And these don't necessarily have to be InSpec. You can also plug in the tests for the application code that you're running. You can also plug in the tests for the infrastructure code that you have if your configuration management program system has tests available for it. In this case, I've got just a Linux baseline. So what I've done so far is just instantiated a CentOS 7.2 machine on my laptop, which is not particularly powerful. It's a MacBook Air, so it's not doing anything super strenuous. And it has installed a couple of things that I've told it that I wanted, right? So I recycled this talk, so there's a couple of things in there to set it up for me. And I've commented out what I'm going to do next, which is a hardening protocol. So I've got this devcycle Linux baseline. The guys that originally developed InSpec have a whole set of baseline profiles that they've published on GitHub that you can just totally consume. You just pull them down in this sort of manner, or download them into the InSpec system when you're using it on the command line. So to actually take a look at how naughty my CentOS 7.2 machine sort of bare bones is, I'm just going to run the tests, and we're going to see how it comes out. So there's a few things in here that I probably need to clean up, deprecation as it is. But there's a lot of other tests in here that are based on sort of best practice recommendations for things like sysctl, things like other parameters for audit D, login definitions, and we're also checking sort of basic things, like who owns Etsy Shadow, what's the permissions on that, and figuring out just sort of how far out of alignment that this sort of basic CentOS 7.2 box is for a set of our required practices. So you can see I have a lot of red text there. There's a lot of things in sort of the baseline that aren't necessarily tuned to be the most secure, which is fine. It's good to know that they're there. And down here I've got a bunch of failures for overall in the profile and then the individual tests that are running there. So now I'm going to flip it around and I'm going to do consume another component of the piece, which is actually the thing that's going to fix all of these. So this is sort of the part that you could, as an infrastructure engineer, give to your application engineers to say, here's your baseline. If you are going to deploy your code on a CentOS 7.2 machine, here's the security profile that you need, and here's the baseline hardening that goes with it. If you run both of these things and your code, and something still comes out red, you've done something wrong, and you either need to talk to security or fix it. So I'm going to open up my kitchen.yaml file again. And I'm just going to pull back in this recipe that goes along with this Linux baseline. And these are both freely available from GitHub. You can download them and use them yourself. And then I'm going to rerun my configuration management, kitchen converge. See how that goes. This is where the music should play. You never know how long these things are going to take. All right, we'll give that a second. And go back to the slide here. We'll let that fix things. And here's a blown up version of what I actually have in my file, so you can actually see what's going on here. I'm just pulling down the profile right from GitHub, in this case, to pull it, to save it into my machine. You can share these other places internally to your team. So if they are on like an internal server or whatever, it's all fine. Ours just happen to be on GitHub right now. So this profile is all together. The thing that I pulled down is a big profile. You saw there's lots of tests in it that failed, right? So the profiles give you the ability to package and share all of these InSpec tests with all of your teams in a way that makes sense for you. So what I have here is OS hardening, right? So it's just sort of baseline operating system stuff for Linux. But you could also publish one for your middleware team, for your front-end team, to make sure the things that they're doing meet your requirements, right? For things more like PCI or something like that, where you're digging around and you can be very specific about who is allowed to have an account on the system and who's not, and other stuff like that, and publish them so that all of your application engineers can consume them. So each profile can have lots of tests, and most of the time we organize them by outcome, but not necessarily. You'll see in some of the ones that we have published that, especially for things like CIS or others, they're categorized by type of thing on the system, so like the system files or services or whatever. You can organize them that way. But the whole thing is super flexible, and you can create what you need to with it. So that's our example basic hardening. So let's see how far we got. So there we go. I've gone through, and this is the hardening part, right? So it's hopefully, right, fingers crossed, fixed all the things that came up as red. So the permissions that weren't necessarily exactly as they should be on things like Etsy Shadow, or the kernel settings that maybe weren't as tight as they could be straight out of the box. And then I can rerun my verify, and all this is going to do is rerun my test suite to make sure that the changes that I've made now make my tests pass, essentially, right? Because that's all we want. We just want green. So see how we go here. Oh, there we go. We've met our goal for the day. So I know that with this pair, I can give these to my application engineers, I can give them to my operations engineers. Anytime they want to make a change that's going to end up in production, they know they have to meet these requirements via this testing language and this sort of testing workflow. Okay. So there's how they work together. You can take a look at what's in the OS hardening cookbook. As I said, it's like system level stuff, pretty basic as far as the things that it will do. We ran it, we saw our fixes from our failures. And then what the actual profile then ends up looking like, you can test a single resource for a lot of things. So you're testing a file, thinking about what I care about with that file. I care about who owns it, I care about the group that owns it, I care about the mod on it, things like that. And you can test all of those things against every resource that you want. So over time, what we hope is that the security pieces become part of your life cycle. We want to make it easy so that when you get to production, your application says, well, I really needed this hole poked in the firewall on the system, so you can say, well, you should have known. Like, we have that in the profile. It would have failed your tests early on, and you could have talked to us 4 months ago instead of when you were ready to deploy. So you can actually get in front of a lot of those issues. So you can build a comprehensive set of checks for everything that you've got, run them every time someone makes a change. They can run them locally as they're doing their local development. You can plug it into your workflow, into your build servers, and then hopefully make it easier and easier for people to use them all the time. So some resources, InSpec lives at inspec.io, Kitchen lives at kitchen.io. We have a bunch of training and workshops on our GitHub repository. There's a whole lot of stuff on InSpec. A woman by the name of Annie Hedgepeth used InSpec as a vehicle to get her back into the workforce after being off, like raising little kids, right? And she now works for one of our partners in Chicago, but it's a super interesting, like 11-part blog about working with InSpec and digs into some of the things I talked about. You can also join our Slack, and if you're interested in the sample, my code is up as well. Finally, I'll push our summit. We're here next week at Fenchurch Street, talking to the rest of our community. We'll have a couple of folks that have been using InSpec for a while, and talking about like their journey towards being more secure and more conscious of how their security and compliance affects their workflow and their speed of agility and all that stuff. So, thanks.
Good stuff, excellent. Thank you very much, Mandy. Okay, so does anybody have a question for Mandy? Rory, I knew I could rely on you.
So I realise that with SSH just might be academic, since most people use the SSH out of the box, but for other things like web servers, Apache's quite often ran from source or from a different than the OS package. How does its protocol, how does it find out what the protocol is? And how will it account for?
So for some of the built-in resources, there's, for Apache, for Nginx, for a number of other ones, there's actually a Partstring class built into the InSpec package. So it has the things that it knows about in those files. So if you have something that you've really deviated from sort of the norm, you might have to go and either patch that class or make a custom resource to deal with those changes that you've made. It's all Ruby under the hood, so there's a lot of inheritance you can have for the parsers to sort of build your own, and it'll figure everything out for you.
I just figured that could break the whole security thing.
What's that?
I just figured that could break the whole security thing, because if I give somebody a security spec, and it turns out that person has used third-party things.
Yeah, like one of the things that we've run into, we saw with a lot of our customers, is that every team sort of had their own thing that they were doing, or they had their own deployment for different components, and this ends up being a really nice tool for them to.
That's right. Rory.
Thanks. Could we use this to bin off Tripwire and get rid of our Tripwire license cost?
I would love to tell you that yes. However, it depends on what you're doing with Tripwire. Like, you can see from the way some of these things are defined in the InSpec profiles is that you have to be very explicit at the things you want to test. So if you're using Tripwire in a limited way and not doing like a universal system catalog, like you can start to sort of port that stuff over to something like InSpec in a more efficient manner. If you're doing just sort of a blast, grab the entire system with your IDS, then it translates less. Like it would be a lot more work to probably get things to really.
I mean, we have a PCI environment, so we've obviously got Cat 1, Cat 2, Cat 3.
Yeah.
Just getting the idea of different profiles based on different categories.
Yeah, you can definitely get that far.
Thank you.
Okay, right, that's a bit noisy. Any more questions from Andy? No? Okay, Mandi Walls, thank you very much.
Thank you.